Picture this. 10,000 years ago, in the grasslands of what is now Argentina, a shape rises up out of the tall grass. It stands on two legs, using its tail like a tripod for balance. It is taller than a giraffe's shoulder, heavier than a pickup truck, and at the end of each arm sits a set of curved claws nearly the length of a kitchen knife. This is not a dinosaur. It is not a myth. This is Megatherium, the giant ground sloth. And for millions of years, it was one of the hardest animals on the planet to kill. Most Americans grow up picturing sloths as slow, harmless, almost comically gentle animals, hanging upside down in a rainforest canopy, moving so little that algae grows on their fur. Megatherium breaks that picture completely. It was not a tree dweller. It walked the ground on massive hind legs, and when fully grown, it weighed somewhere between 4 and 8 tons, roughly the same as a modern African bull elephant, sometimes more. From nose to tail, it could stretch over 20 feet long, and when it reared up on its back legs to feed, it could reach nearly 20 feet into the air. For comparison, that is taller than a 2-story house. This was not a small, easy meal wandering the Pleistocene landscape. This was one of the largest land mammals to ever walk the Americas, and everything about its body seems built to make sure nothing could bring it down easily. The name itself comes from Greek, combining the words for great and beast, and it was first scientifically described all the way back in 1796 by the French naturalist Georges Cuvier, based on bones recovered near the Lujan River in Argentina, making Megatherium one of the very first extinct giant mammals ever formally recognized by science, decades before anyone had even coined the word dinosaur. Let's start with the claws, because they are the single most misunderstood part of this animal. Most people assume an herbivore's claws are for digging or stripping bark, and Megatherium's claws did do that. But paleontologists who studied its arm bones found something strange. The olecranon, which is the part of the elbow where the triceps muscle attaches, was unusually short in Megatherium. In most animals built for raw pulling strength, that bone is long, giving the muscle more leverage to generate slow, powerful force. A short olecranon does the opposite. It sacrifices raw strength for speed. That is a trait typically seen in fast, active predators, not slow-moving plant eaters. Researchers Richard Farina and Ernesto Blanco, working with fossil skeletons in Uruguay, proposed that this anatomy would have let Megatherium swing its claws quickly, almost like a swordsman, rather than just slowly hooking branches toward its mouth. Some of those claws measured close to 7 inches long. Imagine a limb that can move fast enough to slash, tipped with hooks the size of small daggers. That is not a defense mechanism you casually test. And this leads to one of the strangest theories in the whole Megatherium story. A few researchers have floated the idea that this giant plant-eating sloth may not have been strictly vegetarian. The theory suggests it might have occasionally scavenged carcasses or even used its size and claws to muscle in on a kill made by a saber-toothed cat, essentially stealing the meal from a predator that wouldn't dare argue with an 8-ton animal armed with sword-length claws. This is still debated among scientists, and most agree Megatherium was primarily a plant eater, feeding on tough leaves, yuccas, agaves, and coarse grasses that needed serious grinding power to break down. But the fact that this debate even exists tells you something. When an animal's own skeleton makes scientists ask whether a sloth might have acted like a predator, you know you are not dealing with an ordinary herbivore. Now let's talk about the stance, because this is where Megatherium becomes almost architecturally strange. Unlike most large mammals, which are built low and wide for stability on 4 legs, Megatherium had a pelvis shaped in a way that made standing upright not just possible, but apparently comfortable and common. Its tail was thick, heavily muscled, and built to bear weight, functioning almost like the third leg of a tripod, the same way a kangaroo uses its tail to balance while it isn't hopping. With that tripod stance, a rear legs and tail base, Megatherium could free up its front limbs entirely. That meant it could stand fully upright, using its back legs and tail as an anchor, and reach nearly 4 meters into tree canopies that no competing herbivore around it could touch. Fossilized trackways, meaning actual footprints preserved in ancient mud, show clear evidence of this bipedal walking behavior. Some researchers consider Megatherium the largest bipedal animal known to have ever existed, dwarfing even the biggest two-legged dinosaurs in raw body mass, even though it usually moved around on all fours like a typical quadruped. Think about what that upright stance meant for defense. A 4-ton animal standing on its hind legs, using its tail as a stabilizing tripod, with both front limbs completely free and armed with foot-long slashing claws, is not a target that invites a direct attack. It's the biomechanical equivalent of a heavyweight boxer who can also kick with both legs at once. Fossil evidence backs this up. Some Megatherium skeletons show healed injuries consistent with defensive combat, with the pattern and placement of the wounds matching what you'd expect from wide, sweeping claw strikes used to keep something at a distance rather than offensive attacks used to bring something down. Here's a fact that surprises almost everyone outside of paleontology circles. Some of Megatherium's close relatives among the ground sloths, particularly a related group called mylodontid sloths, actually had bony armor built directly into their skin. These are called dermal ossicles, or osteoderms, small nodules of bone embedded in the hide itself, similar in concept to the armor plating found in modern armadillos, which are actually distant cousins of sloths. Mummified sloth skin recovered from a cave in southern Chile called Cueva del Milodon showed these ossicles arranged in different patterns, some scattered randomly, some in organized rows, and some clustered into star-shaped rosettes. Researchers studying this armor believe it evolved as protection against predation, possibly from large carnivorous birds and marsupial predators that hunted smaller, earlier sloth ancestors millions of years before Megatherium existed, with the trait potentially being inherited and carried forward even as the sloths grew to enormous size. Whether Megatherium itself had this same skin armor is actually still an open and genuinely contested question in paleontology. Some ossicles found at archaeological sites in Argentina have been tentatively linked to Megatherium americanum, but they were never properly described or cataloged in scientific literature, so their true identity remains unconfirmed. It's entirely possible that Megatherium had some form of this hidden bony underlayer built into its skin, and paleontologists simply haven't found definitive proof yet. Considering how rare it is for soft tissue and skin to fossilize at all, this is a mystery that could be rewritten with a single new fossil discovery. There's another detail about how Megatherium actually moved that most people never hear about. Because its claws were so long and curved, it couldn't simply plant its palms flat on the ground the way most four-legged mammals do. Doing that would have driven the tips of its own claws into its wrists with every step. Instead, fossil trackways and skeletal analysis suggest Megatherium walked on the outer edges of its hands, essentially knuckle walking in a way that's more commonly associated with gorillas and chimpanzees, curling its claws inward and out of the way so it could move across open ground without stabbing itself. It's a strange, almost gorilla-like adaptation on a creature most people picture as nothing more than an oversized, slow-moving cousin of a modern tree sloth. Its feeding style adds another unexpected layer. Richard Owen, the British anatomist who first scientifically described much of Darwin's fossil material, examined a Megatherium skull and concluded that the neck had considerable freedom of movement, powered by unusually large and strong neck muscles. Combined with evidence of a large, flexible tongue, some researchers have suggested Megatherium may have fed somewhat like a modern giraffe, using that muscular tongue to grip and pull leaves and branches toward its mouth once it had reared up into the canopy. Interestingly, that same skull examination revealed something almost comedic in comparison to the rest of the animal. Owen concluded that Megatherium's brain was proportionally tiny, smaller by nearly half compared to an elephant's brain relative to body size. This was an animal that combined the raw physical toolkit of an apex predator with the mental horsepower of, essentially, an enormous grazing herbivore. It didn't need to outthink anything. It just needed to be too big, too fast-clawed, and too well-armed to be worth the risk. There's also a distinctly American thread buried in this story that most people in the United States have never heard, despite it involving one of the country's founding fathers. Long before Megatherium was formally known to American audiences, Thomas Jefferson became fascinated with strange oversized fossil bones being unearthed on the American frontier. In 1797, 4 years before he became president, Jefferson received a set of massive claw bones discovered in a cave in western Virginia, in what is now West Virginia. Believing he might be looking at evidence of an enormous, still-living American lion, Jefferson presented his findings to the American Philosophical Society and even asked members of the Lewis and Clark expedition to keep an eye out for a living version of the creature as they explored the western frontier. The animal was eventually identified as an extinct ground sloth, related to Megatherium but smaller, and was later named Megalonyx jeffersoni in his honor. When Darwin himself later found his first Megatherium skull fragment at Punta Alta, he initially wasn't sure if it belonged to Megatherium or to this very same Megalonyx lineage, showing just how closely intertwined these giant sloth discoveries were across two continents and two very different moments in scientific history. Size comparisons help put all of this in perspective for a modern audience. Megatherium is estimated to have weighed as much as, and by some estimates more than, a full-grown African bull elephant, currently the largest land animal on Earth. Only a handful of other land mammals in history have ever matched or exceeded its bulk, mainly large elephant relatives, and the enormous extinct rhinoceros relative Paraceratherium. Evidence also suggests Megatherium didn't necessarily live a solitary life. Fossil sites containing multiple individuals of different ages hint that they may have moved in loose family groups at least some of the time, though some researchers believe older or larger individuals may have also spent time alone, possibly denning in caves, similar to behavior seen in some large modern mammals. So, who actually wanted to hunt an animal like this? During the time Megatherium walked South America, the continent was home to some of the most dangerous predators in mammal history. Smilodon, the saber-toothed cat, prowled the same grasslands, an ambush predator with canine teeth built for delivering a single devastating bite to soft tissue. Arctotherium, sometimes called the giant short-faced bear, was one of the largest bears to ever exist, a massive and powerful carnivore that could have rivaled polar bears in size. Both of these animals were apex predators capable of taking down large prey. And yet, the evidence strongly suggests that adult Megatherium simply wasn't on the menu very often. The combination of raw mass, upright reach, tripod stability, and slashing claws made a healthy, full-grown individual an extraordinarily costly target. Predators are opportunists. They don't attack prey that could kill or seriously injure them just as easily as they could kill it. A miscalculated attack on an adult Megatherium could mean a shattered jaw, a torn eye, or worse, and in the wild, an injury like that is often a death sentence on its own, since a wounded predator can no longer hunt effectively. It's far more likely that young, sick, elderly, or isolated individuals were the ones occasionally targeted, while a healthy adult in its prime moved through the landscape with very little to fear from any other animal. That changed when humans arrived in the Americas, and this is where the story gets genuinely eerie. In White Sands National Park in New Mexico, researchers uncovered something remarkable preserved in ancient lakebed sediment, a set of fossilized human footprints stepping directly inside the footprints of a giant ground sloth, creating overlapping tracks that tell an actual moment-by-moment story. The pattern shows humans circling and following the sloth, seemingly hurting or provoking it, while the sloth's own tracks show it pivoting, likely rearing up in that same defensive tripod stance, probably swinging its claws to keep the threat at bay. This isn't speculation drawn from bones alone. These are literal footprints, a snapshot of an actual hunting encounter frozen in stone for over 10,000 years. It shows that even though Megatherium was extraordinarily difficult prey, humans hunted it anyway, likely using coordinated group tactics, distraction, and persistence rather than brute force, because no single hunter with a spear was going to walk up and win a fight against an animal that outweighed a car. That combination, coordinated human hunting pressure layered on top of a rapidly changing climate at the end of the last ice age, is generally considered the leading explanation for why Megatherium eventually went extinct, roughly somewhere around 10,000 years ago, which in evolutionary terms is essentially yesterday. For context, that means Megatherium was still walking the earth after the pyramids of Giza were already old news in some early human timelines, depending on which extinction estimate you use, and it overlapped with early human civilizations far more recently than most people realize. This wasn't some ancient creature lost in deep geological time like a dinosaur. This was a massive, heavily defended, genuinely dangerous animal that shared the planet with our own ancestors, got hunted by them, watched its world change around it, and still couldn't survive the pressure. There's one more twist to this story that connects Megatherium directly to the history of science itself. In 1832, a young naturalist named Charles Darwin, only 22 years old and sailing aboard the HMS Beagle, went ashore at a cliffside site called Punta Alta in Argentina to search for fossils. He spent nearly 3 hours digging a large skull out of soft rock, initially believing it belonged to some kind of ancient rhinoceros. It turned out to be part of a Megatherium, along with the remains of several other extinct giant mammals found at the same site. Darwin was struck by something odd. These enormous extinct creatures were clearly related in body plan and bone structure to much smaller living animals found in the exact same region, like modern armadillos and tree sloths. Why would extinct giants and small living relatives share the same geography if species didn't change and relate to one another over time? That question, sparked partly by a Megatherium skull pulled out of an Argentine cliff, became one of the early threads of evidence Darwin carried with him toward his theory of evolution, published decades later. In a strange way, this armored, claw-wielding giant sloth, one of the toughest animals of its era to actually kill, ended up playing a quiet supporting role in one of the most important scientific ideas in human history. So, when you put it all together, you get a genuinely singular animal, a creature the size of an elephant that could stand upright like a person, balance on a muscular tripod tail, swing 7-inch claws with real speed instead of just slow brute force, possibly carry hidden bony armor beneath its skin, and go toe-to-toe with saber-toothed cats and giant bears and simply not lose. Nature spent millions of years building a plant eater that behaved, physically, almost like a heavyweight fighter that just happened to eat leaves. It took the most dangerous predators of the Ice Age and eventually the coordinated intelligence of early humans to finally bring an animal like this down. Megatherium wasn't just big, it was engineered through millions of years of evolutionary pressure to be almost impossible to kill.